Okay, so welcome members. Now we are going to see how do we handle these figures or this data when we are given decimal places. So please don't forget subscribe to the channel. Okay, start with the set. All this data we are having is ungrouped. First of all, we say you can convert to grouped data by using the TAL method of tiling the data here. So what we do here, the table below shows the length of pipes in meters. Is the length. Starting with the class of 6.0 to 6.3, calculate the frequency, construct a frequency table. So how do you construct the frequency table? Now, if they give you the first class 6.0 to 6.3, it's there. Now to get other classes, what I do, I first get the width on the class interval, the class boundary, the class width or size of this. What we do, we get this minus this. Then we add plus 0.1. If this is one decimal place, you add 0.1. If it's two decimal places, you add 0.01. So if it's one decimal place, then you add this 0.1, which is 0.4. So different other classes, this class width we have here, you add it and the lower. When you add it the lower, you get the next lower. So when you add 0.4 here, I'll get 6.4. Then when you add it here, you get 6.7. When you add now this to get the next. Now, so that my lowest in this table, you see it's going to be, my lowest is going to be 6.2. My lowest value is 6.2. What about my highest? My highest in this table is going to be, is it 7.8? Yes, my highest I think is 7.8. So my value highest is going to be 7.8. Now, your classes should cover the lowest and the last class should cover the highest. So my lowest is covering. Then my highest, then the last class should cover this, the highest value or the highest length in these ones. So now I've not reached this class which is covering this. So I add still 0.4. This will be 6.8. Then I add here 0.4. I'll get 7.1. Add 0.4 here, you get 7.2. Add 0.4 there, you get 7.5. Instead, you have not covered this already. So then you add 0.4 still, you'll be adding 0.6. Then you add also 0.4 there, you get 7.9. And instead, we have covered it there. So now to get the frequency, I'm going now to start tallying. How do we tally? Now we tally, you cancel, you put a figure there, you put a stick. So 7.3 is in the range, 7.3 is here, you put 6.6. 6.6 is and there. 6.9 is here. 7.1 is here. 7.7 is here. 6.2 is here. Then 7.2 is here. Then 7.1 where is in this range. Then 7.4 is here. Then 6.8 you see it's here. Then 6.4 is here. Then 7.0 is here. Now they are 5, we tally. If they are 5, we tally. Then 6.7 is here. You pause so that you don't repeat a number. 7 is here. 6.9 is still here. 6.5 is here. Then 7.8 is here. Then 7.1 is here. 7.1 is there. Then 7.5 7.5 is here. Then 7.4. 7.4 is also going to be there. So that's how we do the tally. So after that, you count now. 1 will represent the 1. Then these ones are 4, 1, 2, 3, 4. There. This is 5 plus 3, which is 8. This is 5. Every bundle is having 5. Then 2 is there. So when we add all these ones, we should get this is 5, 13, plus 7, that's 20. Now, know that you have your tallies are okay. This figure here, the frequency, you come and you count these ones, they should be equal. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. So if you multiply them, you start out with 20. So that's there, okay. Then to get the class, because you need the mean, you need f of x. So you need to get x. You get this plus this divided by 2. This is what you get. This plus this divided by 2 there. This plus this divided by 2 the same. This plus this by 2 there. And so on. But the easiest method I told you, if you get the class with this, if you get the first, you just add on the class with this. You add the 0.4 here, you get this. 0.4 here, you get this. 0.4 here, you get that. 0.4 there, you get that. And so on. As simple as that. Then to get our f of x, we multiply f and x. This time this, you get this. This time this, you get this. This time this, you get this. And so on like that. Then, to get our geometric frequency, we say the first frequency is always the first line. Then this plus this, you get this. This plus this, you get this. This plus this, you get this. Then this plus this, you get this. Understand this? The last geometric frequency will be equal to the sum of all the frequencies there. So now, to get our mean, now we need class boundaries because we are going to calculate the mode and median. So now we need the hour density factor. How do you get it? You get the difference between this and this, or the difference between this and this. So this minus this divided by 2. So the difference you get divided by 2, this is what? Now this is my adjustment factor. So this one is that you subtract here and you add here. When I subtract 0.05 here, I get this. When I add 0.05 here, I get this. Subtract it here, you get this. You add it here, you get this, and so on up to when you reach that side. So when you subtract 0.05 here, we get this, and when you add it here, we get this. But I tell you the simple method, this will be here. So don't waste all this time. If you have and they are uniform, I mean the uniform class. What is here is going to be here. What is here is going to be here. So just keep on adding there. So now my mean, which is summation f of x over summation f, it's here, divided by this, and that's the answer we get. Then our median is the lower class boundary plus summation f over 2 times, then plus I. So now, we first always compute this. When you compute this, our summation f is 20. Divided by 2, you get 10. Then you come for the position value of this 10 in the geometric frequency. So we look for this in the geometric frequency. So it's that it's not this in the geometric frequency column. This is not 10. We have not reached 10. Not yet. And we have reached 10 here. So now this 10 is going to be here. Now we use this row, the whole of this row here, from here up to here. The values we are going to use. Now, our Laplace boundary in this row is going to be this. Then, summation f over 2, we have seen it's 10 there. Then, geometric frequency before is 5. Then, over geometric frequency within this row is 8. Then times I, the class width, which is here. How do you compute? You set this minus this, then the answer, you divide it by 8, then the answer times this, then the answer plus this. That's how you make an accurate answer. Then the mode is given by this plus this, dA plus dB times I. This dA, I mean the frequency above the one in the median class. We have seen that our median class is going to be this one. So we use also this column. So to get always the mode, you always first compute this one so that you can get the median class. So now, after doing that, you see that dA, you get the frequency of the median class minus the frequency above. That's why I'm having A. Frequency above it, here we deal with the above. Above it is this. So the difference is going to be 4. Then dB, the frequency of the median class minus the frequency below it. This is the median class frequency. Minus 5. You got a 3 there. That's why I have 4. 4 plus 3 times I. I've told you first compute this, then you add this. That's the answer you get. To 4 decimal places, you put their units. Then the third quartile, you also first compute now this. When I compute this, I have this times this, which will be this position value. Now I am in the total frequency. I look for this value. It's not here, it's not here, it's not here. I've not reached 15 yet. But here is that I've reached 15 and even I'm not seeing it. So this is now the row I'm going to use. Meaning that the lower class bound that I need is this. Then when we compute this, summation of this over, we got 15. That's why I'm having 15. Made the frequency before is 13 over frequency within of this, where this cumulative frequency will be falling. So the frequency within is 5 times the class boundary. I mean the class width, which is this, and then the compute. That's what you get. So that's it, members. Unless you have a question, you leave it there in the comment section. I wish you well.